Look up at the night sky and tell me what you see. You see stars, planets, and the comforting ancient glow of distant galaxies. But between those points of light lies a darkness that you have always assumed is merely empty space, waiting to be filled by gravity. We are taught that the universe is uniform, a tapestry where matter is spread out like butter on bread, predictable and safe. But that safety is a lie, because in a specific corner of the southern sky, the universe has stopped behaving according to the laws of physics. Something is wrong with the data coming from the Eridanus constellation, and it is terrifying the astronomers who are brave enough to look at it. They found a region where the temperature drops to near absolute zero, a statistical impossibility that suggests something is draining the energy from our reality. This is not just the gap between stars. It is a 1 billion light-year wide abyss where matter, light, and time seem to simply vanish. If you were to travel into the center of this void, you would not just be in darkness, you would be effectively removed from the universe itself. Scientists call it the CMB cold spot, but that clinical name hides the true nature of what we are actually looking at. The standard model of cosmology says this structure cannot exist, yet it is sitting there, staring back at us like a missing pixel in a simulation. When the WMAP satellite first scanned the cosmic microwave background in 2004, researchers thought their equipment was broken because the numbers didn't make sense. They recalibrated, they checked the mirrors, and they ran the numbers again, hoping the anomaly would disappear into the noise of the cosmos. But the anomaly remained, a massive bruise on the face of the infant universe that refused to heal over billions of years of expansion. Imagine a hole so vast that it could swallow 10,000 Milky Way galaxies and still have room for millions more to disappear without a trace. This is not a black hole which crushes matter into a singular point. This is something far worse, something that repels existence itself. Theories began to circulate in the darker corners of academia, whispering that this might be the footprint of a collision with another universe. If that is true, then we are not looking at empty space, but at a bruise left behind, where a parallel reality crashed into our own. The energy in that region wasn't just moved, it was seemingly erased, violating the first law of thermodynamics in a way we cannot explain. Every time we point our most advanced sensors at this region, the silence gets louder, more oppressive, and infinitely more terrifying. It feels like we are standing on the edge of a cliff at night, unable to see the bottom, but knowing something is waiting down there. The implications of this discovery suggest that our universe is not a sealed bubble, but a fragile membrane that can be punctured from the outside. If something punched a hole in our reality billions of years ago, the structural integrity of the cosmos might already be compromised. We assumed the vacuum of space was the baseline of reality, but this supervoid suggests that the vacuum itself can decay into something lower. The atoms in your hand, the air in your lungs, and the fusion in the sun all rely on the stability of the vacuum state. If that stability is an illusion, then everything we know could unravel at the speed of light without any warning whatsoever. Some physicists argue this is just a statistical fluke, a random roll of the cosmic dice that resulted in a cold patch. But the probability of a void this size forming by chance in the standard model is less than 1 in a billion. We do not live in a universe that allows for 1 in a billion coincidences on this scale without a physical cause driving them. The cold spot is a crime scene, and the victim is the fabric of space-time itself, left bleeding energy into the unknown. Even more disturbing is the fact that this region lacks roughly 10,000 galaxies that should be there but are missing. Where did they go? Were they never born? Or were they swallowed by the anomaly as it expanded through the early universe? The sheer scale of the missing matter is equivalent to deleting the history of trillions of stars and potential civilizations. We are looking at a cosmic graveyard where the headstones have been removed, leaving only a cold, empty wind blowing through the dark. In 2015, the Planck satellite confirmed the data again, removing any hope that this was just an error in our instruments. The hole is real, it is colder than the rest of creation, and it defies every model we have for how the universe grew. We have to ask ourselves if we are observing a natural phenomenon or the aftermath of a catastrophic event that predates time. Could it be a vacuum decay bubble that started and then stopped, frozen in time like a crack in a windshield? Or is it the gravitational shadow of a superstructure that exists in higher dimensions, pushing against our three-dimensional world. The multiverse theory moves from science fiction to terrifying probability when you try to explain why this scar exists on our sky. If we are just one bubble in a cosmic foam, then collisions are inevitable, and this void is the evidence of impact. But there is a darker hypothesis, one that suggests the void is not an external wound, but an internal rot spreading outward. If the dark energy in that region is behaving differently, it could be the epicenter of the Big Rip that will eventually tear us apart. We are small creatures living on a dust mote, trying to understand why a chunk of the ceiling is missing above our heads. The fear is not just in the unknown. The fear is that we are finally seeing the walls of our cage for the first time. Every astronomer who studies the cold spot eventually has to confront the limits of human comprehension and the terror of the infinite. It mocks our physics, it breaks our math, and it stands as a silent monument to how little we actually understand. We are about to dive into the specific numbers that make this anomaly impossible, and you need to prepare yourself for the truth. Because once you understand what the cold spot implies, you will never look at the night sky with the same sense of peace again. The universe is not a safe harbor. It is a stormy ocean, and there is a hole in the hull of our ship. Let us examine the evidence, trace the photons back to the source, and stare directly into the abyss that is staring back at us. To truly understand why this anomaly terrifies the scientific community, we must first understand the map upon which it was found. We are talking about the cosmic microwave background, or CMB, which is effectively the baby picture of our universe. This is the oldest light in existence, a fossilized relic of radiation left over from the Big Bang itself, streaming toward us from a time when the cosmos was only 380,000 years old. Before this moment, the universe was a hot, opaque fog of plasma where light was trapped, bouncing endlessly between charged particles. When the universe finally expanded and cooled enough for atoms to form, that fog lifted, and light was set free to travel through the void. What we see today as the CMB is that ancient light, stretched by billions of years of cosmic expansion into the microwave spectrum. It surrounds us completely, a uniform glow that serves as the backdrop for every star and galaxy you have ever seen. It is the ultimate baseline of reality, the canvas upon which existence is painted. And for decades, cosmologists believed this canvas was perfectly smooth. The standard model of cosmology relies on the assumption that on a grand scale, the universe is isotropic and homogeneous, meaning it looks the same in every direction, and the matter within it is distributed evenly. The discovery of the cold spot shattered that assumption, revealing a flaw in the canvas that suggests the painting itself might be hiding a terrible secret. The uniformity of the cosmic microwave background is not just a preference for aesthetic symmetry. It is a mathematical necessity for the Big Bang theory as we currently understand it. According to the theory of cosmic inflation, the universe expanded exponentially in a fraction of a second, smoothing out any irregularities and leaving us with a cosmos that is uniform to 1 part in 100,000. This means that the temperature of the CMB should be almost exactly 2.7 Kelvin everywhere you look, with only the tiniest microscopic fluctuations caused by quantum jitters in the early universe. These tiny fluctuations are the seeds that eventually grew into galaxies and clusters of galaxies, collapsing under gravity to form the structures we see today. We expect to see a random distribution of hot and cold spots, a Gaussian curve of probability, where extreme outliers are statistically impossible. But the cold spot defies this distribution entirely. It is a region of the sky that is significantly larger and significantly colder than anything predicted by the standard model. While the average temperature fluctuation in the CMB is about 18 microkelvins, the cold spot plunges to around 150 microkelvins below the mean. This might sound insignificant to a layman, but in the precise world of cosmology, it is the equivalent of finding a mountain on a billiard ball. It is a statistical monster, a deviation of such magnitude that it suggests the fundamental dice roll of the universe was rigged from the very beginning. When NASA launched the Wilkinson Microwave Anisotropy Probe, known as WMAP, in 2001, the mission was to map these tiny temperature fluctuations with unprecedented precision. The scientists expected to confirm the standard model, to see a beautiful, random speckling of warm and cool dots that validated their equations. Instead, when the data came back in 2004, they found a massive, deep blue bruise in the southern hemisphere that refused to fit the curve. At first, the skepticism was rampant. The team checked for instrumental error, wondering if the sensors had malfunctioned or if there was some interference from our own galaxy distorting the signal. They looked for foreground contamination, dust, or gas that might be absorbing the microwave radiation and creating the illusion of a cold spot. But every test came back negative. The cold spot was not a glitch in the machine. It was a feature of the universe. It sits in the constellation Eridanus, spanning roughly 5 to 10 degrees of the sky, a gaping maw of low energy that mocks the concept of isotropy. If the universe is a result of random quantum fluctuations, the odds of a spot this large and this cold appearing by chance are roughly 1 in 50, which creates a tension, but not a crisis. However, subsequent analyses have suggested the odds are far lower, perhaps 1 in 1,000 or even less, depending on the model used. This drives a wedge into the heart of the standard model, forcing us to ask, what mechanism could possibly freeze such a massive section of the early universe? As the reality of the WMAP data settled in, the scientific community split into factions, desperate to explain the unexplainable. The most comforting theory was that the cold spot was merely a supervoid, a physical lack of matter in the relatively recent universe that was tricking our eyes. This phenomenon is known as the integrated Sachs-Wolf effect. The logic goes like this. As photons from the CMB travel toward us, they pass through the gravitational wells of galaxies and clusters. When a photon enters a galaxy cluster, it gains energy falling in, like a ball rolling down a hill. When it exits, it spends energy climbing back out. In a static universe, the energy gained and lost would cancel out perfectly. But our universe is not static. It is expanding, and dark energy is accelerating that expansion. If a photon enters a massive void, a region with very little matter, it doesn't gain energy falling in because there is no gravity well. But as it crosses the vast empty space, dark energy stretches the void, making the hill it has to climb out of even steeper and wider. The photon loses significant energy trying to exit this expanding chasm, and by the time it reaches our telescopes, it appears colder or redshifted. This explanation offered a lifeline to the standard model. The cold spot wasn't a scar from the Big Bang. It was just a shadow cast by a massive empty space in the Eridanus constellation. It was a terrifying thought, a void of nothingness, but it was physically allowed, or so they thought. The hunt for the Eridanus supervoid began in earnest. Astronomers turned their optical telescopes toward the cold spot, counting galaxies to see if there was indeed a deficit of matter that could account for the temperature drop. And they found it. In 2015, a team led by astronomer Istvan Saputty discovered a supervoid roughly 1.8 billion light-years across, centered on the cold spot. It is the largest individual structure ever identified by humanity, a titan of emptiness that defies comprehension. To put this in perspective, this void is so large that if you were placed in the center of it, you wouldn't be able to see any galaxies with the naked eye. You would be surrounded by absolute, crushing darkness for hundreds of millions of light-years in every direction. It is a desert in the cosmic ocean, a place where galaxy formation stalled and failed. Finding this supervoid felt like a victory. It seemed to provide the smoking gun that solved the mystery. The headline was simple: largest void in universe causes cold spot. The physics seemed to align. The photons were losing energy as they traversed this barren wasteland, resulting in the cold patch we see on the CMB map. But nature is rarely so kind, and the universe has a habit of punishing us when we think we have solved its riddles. As physicists crunched the numbers, a new horror began to emerge from the mathematics. The supervoid was real, yes, but it wasn't strong enough. The problem lay in the magnitude of the effect. Even a supervoid of this staggering size, 1.8 billion light-years of emptiness, can only account for about 10% to 20% of the temperature drop observed in the cold spot. The integrated Sachs-Wolf effect is a subtle phenomenon. It simply isn't powerful enough to drain that much energy from the CMB photons. To explain the full depth of the cold spot solely through a void, the void would need to be impossible, either defying the laws of gravity or requiring a configuration of dark energy that violates the standard model even more than the cold spot itself does. We are left with a supervoid that is undeniably there, yet acts merely as a coincident symptom rather than the root cause. It's like finding a crater and assuming a meteor caused it, only to realize the crater is radioactive and the meteor was made of ice. The void exists, But it is arguably just as anomalous as the temperature drop. Why is there a hole in the matter distribution of the universe that is 1.8 billion light-years wide? The existence of the Eridanus supervoid itself is statistically improbable. Standard cosmological simulations of the universe's evolution do not produce voids of this magnitude. It is too big, too empty, and too old. So we are back to square one, but with a deeper mystery. We have a hole in the heat map and a hole in the matter map, and neither of them should exist. The failure of the supervoid theory to fully explain the anomaly forces us to look at more exotic and, frankly, more disturbing possibilities. If the cold spot cannot be explained by foreground structures or instrumental error, then it must be a primordial feature, something that happened at the very moment of creation or shortly thereafter. This brings us to the concept of texture in the fabric of spacetime. In the late 1990s and early 2000s, theorists proposed that the universe might have undergone phase transitions as it cooled, similar to how water freezes into ice. When water freezes, the ice crystal isn't perfect. It has cracks and defects where the alignment of the molecules doesn't match up. These are called topological defects. In the context of the universe, a cosmic texture would be a knot of energy, a twisted region of spacetime formed as the fundamental forces separated from one another in the first fraction of a second. If such a texture collapsed or unwound, it could release or absorb massive amounts of energy, leaving a scar on the CMB. Imagine a knot in a fishing line that suddenly snaps tight. The ripple travels down the line. A cosmic texture collapsing could create a localized cold spot exactly like the one we see. However, for this to be true, we would expect to see other specific signatures, specific geometric patterns in the polarization of the light, which the Planck satellite has searched for but has not definitively found. The texture hypothesis remains a valid, albeit unproven, attempt to rationalize the damage we see in the sky. But there is a far more radical hypothesis, one that was once relegated to the fringe of science fiction, but is now being whispered in the halls of prestigious universities. It is the theory championed by physicists like Dr. Laura Mersini-Houghton, the multiverse collision. The idea is based on string theory and eternal inflation. Eternal inflation suggests that our universe is just one bubble in an endless boiling foam of a greater false vacuum. In this model, Big Bangs are happening all the time, popping into existence like bubbles in a pot of boiling water. Each bubble is a self-contained universe with its own physical laws, expanding rapidly. If this picture of reality is correct, then it is inevitable that, occasionally, two of these bubbles will touch. They might rub against each other, or one might nucleate inside another. The cold spot, under this framework, is the bruise left behind from a collision between our universe and another universe. Imagine two soap bubbles floating in the air. When they touch, they flatten against each other, creating a circular rim of contact. If another universe bumped into ours during the earliest epoch of our expansion, it would have pushed against our spacetime, scattering the matter and energy in that region, and leaving behind a distinct, circular cold signature. This collision theory solves many of the problems that the standard model cannot. It explains why the cold spot is circular, it explains why it is so incredibly large, and most chillingly, it explains why it is so cold. Energy was transferred out of our universe, or repelled by the gravitational influence of the other bubble. If this is true, the cold spot is the first observational evidence of the multiverse. It is a window looking out of our reality. But consider what that truly means. It means we are not alone in a much more profound sense than aliens. It means our entire reality is just one atom in a much larger organism. It also implies a terrifying precarity. If universes can collide, they can theoretically destroy one another. A collision with a bubble of a lower vacuum energy could trigger a phase transition, a wave of destruction traveling at the speed of light that rewrites the laws of physics, deleting chemistry, atoms, and life as it passes. The cold spot might be a scar from a fender bender that happened billions of years ago, a lucky escape where we just grazed another reality. But in a chaotic, boiling multiverse, there is no guarantee that the next collision won't be head-on. We are drifting in a crowded highway with no headlights, and we have already been hit once. The data from the Planck satellite, released in 2013 and refined in 2015, was supposed to settle the debate. Planck had higher resolution and better sensitivity than WMAP. If the cold spot was a statistical fluke, Planck should have smoothed it out or revealed it to be a cluster of smaller, unrelated fluctuations. Instead, Planck sharpened the image. The cold spot remained stark and undeniable, staring back at the researchers with even greater clarity. The precision of the Planck data ruled out many of the convenient excuses. It confirmed that the anomaly is inconsistent with the Gaussian predictions of standard inflation at a high confidence level. The axis of evil, a strange alignment of anomalies in the CMB that includes the cold spot, became even more pronounced. It seems that the universe has a preferred direction, an up and down, aligned with our solar system's motion, which should be impossible in a vast isotropic cosmos. This alignment suggests that the structure of the universe on the largest scales is correlated with our local position, a violation of the Copernican principle that states we are not special. This has led some to jokingly and nervously refer to it as the greatest crisis in cosmology. We are forced to choose between admitting our fundamental laws are wrong or accepting that we are victims of a cosmic accident so unlikely it borders on the miraculous. Let's return to the physical nature of the Eridanus supervoid for a moment, because the sheer scale of this emptiness deserves its own existential reverence. While it may not fully explain the temperature drop, the void itself is a monstrosity. In a universe that loves to build structures, grouping stars into galaxies, galaxies into clusters, and clusters into walls/filaments, the supervoid is a region that said, no. It is a repulsive zone. Current simulations of dark matter show that gravity pulls matter into filaments, leaving behind small voids. But a void of this size would take longer than the age of the universe to clear out via standard gravitational collapse. To create a hole this big, you would need a force pushing outward from the center, or a lack of initial seeds so profound that nothing could ever grow there. It is like walking through a dense forest and suddenly coming upon a perfect circle of dead earth, 10 miles wide, where nothing has grown for 1,000 years. You wouldn't assume it's a natural clearing. You would assume something poisoned the soil. In the case of the supervoid, the poison might be a concentration of dark energy, acting more aggressively here than anywhere else, expanding this pocket of space faster than the surrounding universe, tearing apart any protogalaxies before they could light up the dark. The implications of a localized variation in dark energy are catastrophic for our understanding of the future. We currently believe dark energy is a cosmological constant, the lambda in Einstein's equations, meaning it is the same density everywhere and constant throughout time. This assumption leads to the heat death scenario, where the universe expands forever and cools down. But if the Eridanus supervoid is evidence that dark energy can vary, that it can be stronger in some places than others, then the constant is a variable. This opens the door to the Big Rip. If dark energy can clump or increase in strength over time, it won't just push galaxies away from each other. Eventually, it will overcome the gravity holding galaxies together, then the electromagnetic force holding solar systems together, and finally the nuclear forces holding atoms together. The Eridanus supervoid might be a glimpse into our future, a localized preview of the end of days, where space itself becomes so expansive that matter can no longer exist within it. We are looking at a region of the sky that has already died, a necrotic patch on the body of the universe, and we have no way of knowing if this necrosis is spreading. To further complicate the nightmare, we must look at what is missing. We mentioned that thousands of galaxies are absent from this region, but it's not just the visible matter. The inferred dark matter is also missing. Dark matter is the invisible scaffolding that holds the visible universe together. It makes up 85% of the matter in the cosmos. In the Eridanus supervoid, this scaffolding has been removed. Without dark matter, there is no gravitational glue. If you were to pilot a ship through this region, you would find that the fundamental tug of the universe is absent. It is a zone of absolute isolation. The few galaxies that do exist inside the void are lonely outposts, separated by abysses so vast that civilizations arising there would likely never discover the existence of other galaxies. They would believe the entire universe consisted only of their own star system, surrounded by an eternal, impenetrable black. It makes you wonder about our own position. We see a universe filled with light, but are we just in a dense pocket? Is the normal state of the universe actually this cold emptiness and we are the anomaly? The cold spot forces us to confront the possibility that life, structure, and light are the exception, not the rule. There is a concept in information theory called the hole in the world. It refers to a loss of data so severe that you can't even reconstruct what was supposed to be there. The cold spot represents a cosmological hole in the world. When we try to rewind the clock and simulate the Big Bang to produce the universe we see today, the simulation crashes when it tries to replicate irredeness. The math says error. The equations return infinities or zeros where there should be integers. This failure suggests that our physics is incomplete in a dangerous way. We are missing a variable, a hidden force or a hidden dimension that dictated the layout of the early cosmos. Some theoretical physicists have turned to string theory's landscape to explain it. They suggest that the laws of physics themselves might be different inside the cold spot. Perhaps the speed of light is slightly different, or the strength of gravity is weaker. If the constants of nature are not constant, then reality is a patchwork quilt, stitched together haphazardly, and the seams are starting to show. And if the laws of physics can vary from region to region, then there is no universal truth, only local truth. Let's delve deeper into the axis of evil anomaly linked to the cold spot. This isn't just a catchy name. It's a legitimate scientific classification for a pattern that shouldn't exist. When you break down the CMB into multipoles, layers of detail, the large-scale fluctuations align with each other and with the geometry of the solar system. Specifically, the quadrupole and octupole modes of the CMB are aligned. This is like looking at the static on an old TV screen and realizing that the random black and white dots are actually forming a picture of your own face. It suggests that the observer, us, is somehow central to the structure of the universe, which violates the Copernican principle. Copernicus taught us that the Earth is not the center of the solar system, and modern cosmology teaches that the solar system is not the center of the universe. But the cold spot and the axis of evil seem to be pointing right back at us. Critics call it a look elsewhere effect, a statistical bias, but the alignment persists in the data. Is it possible that our local environment is distorting the view? Or is the universe actually smaller than we think, a hall of mirrors that wraps around itself, creating the illusion of infinity while repeating the same patterns? The cold spot could be the seam where the universe folds back on itself. If the universe is finite and wraps around like a torus, a donut shape, or a hypersphere, then light from a galaxy could travel all the way around the cosmos and return to us from the other side. This would mean we might be seeing the same galaxies twice, once in front of us and once from behind. In this finite universe topology, the cold spot might be a focal point, a place where the constructive and destructive interference of light waves crossing the universe cancels out. Imagine a sound wave in a room finding a dead spot, where the acoustics kill the noise. The cold spot could be the acoustic dead zone of the Big Bang's echo. This theory is less violent than the multiverse collision, but it is claustrophobic. It means the infinite frontier of space is an illusion. We are trapped in a closed loop. And if the loop is closing, or if the topology is complex, the cold spot represents the distortion caused by the curvature of the entire system. It is the stretch mark on the skin of a finite reality. This challenges the very concept of infinite expansion and suggests that we are living in a cosmic fishbowl, looking at the glass and mistaking it for the ocean. But what if the cold spot isn't a place, but a time? This brings us to the concept of last scattering anomalies. The CMB is a snapshot of a specific moment, 380,000 years after the Big Bang. But the process of recombination, where protons and electrons combine to form neutral hydrogen, might not have happened instantly everywhere. If the region of space corresponding to the cold spot underwent recombination later than the rest of the universe, or earlier, it would change the temperature we see today. This would imply that the clock of the universe does not tick at the same rate everywhere. Time dilation is a known phenomenon near black holes, but this would be a primordial time dilation, a region where the evolution of the cosmos lagged behind or raced ahead. If time flowed differently in Eridanus during the epoch of creation, it raises the question of what controlled the flow. Was there a massive concentration of mass that slowed down time, or a lack of mass that sped it up? A temporal anomaly of this scale suggests that the Big Bang was not a singular uniform explosion, but a chaotic, uneven eruption where some parts of reality were born before others. The cold spot is a patch of the universe that is effectively younger or older than its surroundings, a temporal scar tissue. Let's reconsider the multiverse collision hypothesis but with a specific focus on the physics of the impact. Physicists Anthony Aguirre and Matthew Johnson have modeled what a bubble collision would look like. They found that it would produce a domain wall, a boundary between the two vacuums. As the collision resolves, this wall expands at the speed of light. Inside the impact cone, the symmetry of the universe is broken. It creates a disc-shaped signature on the CMB. The predictions from their models match the cold spot's size and temperature profile frighteningly well. But the model also predicts something else: polarization patterns. Light vibrates in specific directions. A collision would twist the polarization of the CMB light in a vortex pattern around the spot. While Planck's polarization data is noisy, there are hints of anomalies that haven't been fully ruled out. If this evidence is confirmed by future missions like the Simons Observatory or LIGHTBIRD, it will be the greatest discovery in the history of science. It would prove that universe is a misnomer. We live in a polyverse or multiverse, and it would confirm that our bubble is not isolated. We are floating in a hostile bath of other realities, and the walls are thin. The cold spot is the window, and we are just now wiping the fog off the glass to see what's outside. The horror of the multiverse is not just in the number of universes, but in the variety. String theory allows for $10 carat, $500 different vacuum states. That is a 1 followed by 500 zeros. Each state represents a different configuration of physics. In some, gravity is repulsive. In others, electromagnetism doesn't exist. In a collision scenario, the other bubble likely possesses physics that are incompatible with life. If the domain wall between us and them were to collapse, or if the collision had been more energetic, the exotic physics of the other bubble could have infected ours. It's like a biological contamination. A strangelet or a value of the Higgs field from the other universe could nucleate a phase transition in ours. The cold spot might be a healed wound where the infection tried to enter but was stopped by the expansion of space. It is a scar from a battle we didn't know we fought. We survived the collision, but the dent in our fender is 1.8 billion light-years wide. It serves as a silent reminder that our existence is contingent on the stability of a vacuum that is constantly under siege by the infinite possibilities surrounding it. There is a psychological component to this discovery as well. For centuries, humans have looked at the sky and felt a sense of belonging. "We are made of star stuff," Carl Sagan said. It connected us to the cosmos. But the cold spot breaks that connection. It tells us that parts of the cosmos are broken, empty, or alien. It introduces the concept of the uncanny valley to astronomy. When something looks almost perfect, but has a single, glaring flaw, it evokes a sense of revulsion and dread. The cold spot is the flaw in the perfect face of the universe. It makes the rest of the sky feel artificial. Are we living in a simulation? A glitch of this magnitude is exactly what you would expect in a rendered environment that is running out of memory or processing power. If the universe is a simulation, the cold spot could be a region where the rendering engine failed to load the assets, leaving a default null texture. This hypothesis, while philosophical, aligns disturbingly well with the pixelation of space-time at the Planck scale and the information limits of black holes. Is the cold spot a buffer underrun in the code of reality? Let's step back to the hard science of non-Gaussianities. The standard model assumes a Gaussian distribution, a bell curve. This assumption simplifies the math and makes the universe solvable. But the cold spot is a non-Gaussian feature. It has kurtosis, a heavy tail in the probability distribution. This means the extreme events happen far more often than they should. In financial markets, non-Gaussian behavior leads to crashes that, quote, shouldn't happen in a million years, happening every decade. In the universe, it means that catastrophic deviations from the norm are built into the system. If the universe is non-Gaussian, then our predictions about the future are likely wrong. We assume the stability of the solar system, the stability of the sun, and the stability of the galaxy based on Gaussian averages. But if the cosmos has a heavy tail, then rare, destructive events are lurking in the probability distribution, waiting to manifest. The cold spot is one such event that has already happened. What other statistical monsters are waiting in the data, or in our future? We are betting our survival on a game of chance where we don't actually know the odds. The sheer energy difference represented by the cold spot is staggering. To cool a region of space that size by 150 microkelvins requires the removal of an astronomical amount of energy. Where did the energy go? In a closed system, energy is conserved. It can't just vanish. Did it convert into mass? No, the region is a void. Did it convert into dark matter? Unlikely. The energy deficit suggests a leak. This brings us back to the idea of higher dimensions. String theory posits 10 or 11 dimensions. Gravity is the only force that might be able to leak across dimensions. The brain world scenario. If the cold spot is a drain, it could be a point where gravitational energy is leaking out of our 3D brain and into the higher dimensional bulk. We might be losing the universe, drop by drop, through a hole in Eridanus. Over billions of years, this leakage creates the cold signature. It's a chilling thought. Our reality might be deflating, slowly losing its essence to a dimension we cannot see or touch, and the cold spot is the valve. While we focus on the cold spot, we must acknowledge its sibling, the great attractor. In the opposite direction of the sky, everything is being pulled toward a massive gravitational anomaly. The cold spot pushes, or is empty, and the great attractor pulls. Are they connected? Is the universe tilting? Imagine a table that isn't level. Everything slides to one side. The dipolar nature of the universe, a cold void on one side and a massive attractor on the other, suggests a flow. We are not static. We are rushing through the cosmos at 600 kilometers per second, caught in a current we can't see. This bulk flow, or dark flow, carries galaxy clusters toward a point beyond the observable universe. The cold spot might be the upstream of this river, the empty headwaters, while the great attractor is the downstream rapid. We are just debris floating in a cosmic river that flows from a void to a singularity, and we have no control over the journey. The scale of this flow is larger than the observable universe, implying that the structures we see are just a tiny part of a much larger, moving system. The visual of the cold spot on the CMB map is deceptive. It looks like a flat blue blob. But in 3D space, it is a tunnel, a cone of emptiness extending from us back to the edge of time. When we look into it, we are looking down the barrel of a gun. The deeper we look, the further back in time we go, and the void persists. It is not a localized bubble. It is a structural pillar of nothingness. This challenges the cosmological principle, which states there are no special places in the universe. A billion light-year tunnel of void is a very special, very distinct place. If you lived inside it, your cosmology would be radically different. You would think the universe was cold, dark, and dying. Maybe the only reason we are optimistic about the universe is because we live in a warm, dense, lucky patch. Our entire philosophy of existence, our hope for the future, is biased by our location. The cold spot reminds us that for vast swaths of the universe, the lights went out a long time ago. Let's talk about the end of greatness. This is a cosmological term referring to the scale at which the universe becomes smooth. Below 300 million light-years, the universe is clumpy. Galaxies, clusters. Above that, it should be smooth. The cold spot, at nearly 2 billion light-years, violates the end of greatness. It proves that clumpiness exists at the largest possible scales. This means there is no scale at which the universe is simple. It is complex all the way up. If there are structures larger than the end of greatness, it implies that the Big Bang was not a simple expansion, but a complex, turbulent event with weather. Just as a storm on Earth has structures, clouds, eyes, rain bands, the Big Bang had storms. The cold spot is a fossilized hurricane eye from the moment of creation. And if there are storms on that scale, there is no reason to believe they have stopped. The weather of spacetime might still be active, shifting voids and superclusters around over eons, changing the climate of the cosmos in ways that could make our region uninhabitable in the deep future. Critics often argue it's just a statistical fluctuation. If you look at clouds long enough, you see a face. But the cold spot has withstood every statistical test we have thrown at it. The look elsewhere effect penalizes you for searching for anomalies. But even after applying the penalty, the cold spot remains significant. P-value, roughly 0.02 or 2%. It's rare, but not impossible. However, the combination of the temperature drop in the missing galaxies and the lack of dark matter makes it a, quote, coincidence of coincidences. In science, when you have to stack three coincidences on top of each other to explain an observation, you are usually wrong. The simplest explanation, Occam's razor, suggests a single cause, and the single cause that explains all three is a collision or a structural defect. We are clinging to the coincidence explanation because the alternative, new physics, is too frightening to contemplate. We prefer a universe that is random and lucky to one that is scarred and broken. What if the cold spot is a signal, not a radio signal, but a beacon? In the zoo hypothesis of the Fermi paradox, advanced civilizations might isolate us or create zones of non-interference. Could a void be a form of cosmic engineering? A Kardashev Type 3 civilization has the energy to manipulate galaxies. If a civilization wanted to hide or wanted to create a barrier, clearing out a region of space 2 billion light-years wide would be the ultimate moat. It sounds like fiction, but Dyson spheres are accepted theoretical physics. A Dyson void, mining every star and galaxy in a region for energy, would leave behind exactly what we see: a cold, dark, empty spot. Is the cold spot the footprint of a civilization that consumed everything in its path? The lack of waste heat, infrared, argues against this, as usually energy usage creates heat. But a sufficiently advanced civilization might capture the heat too. We look at the cold spot and see nature. Perhaps we should be looking for artifacts of industry on a godlike scale. The philosophical weight of the cold spot is heavy. It represents the unknown unknowns. We built the standard model of cosmology over 100 years. It explains the expansion, the elements, the age of the universe. It is our cathedral of knowledge. The cold spot is a crack in the foundation of that cathedral. If the standard model falls, we lose our creation myth. We lose our certainty about the age of the universe. 13.8 billion years might be wrong if inflation was uneven. We lose our certainty about the composition of the cosmos. The cold spot threatens to return us to a state of ignorance. This is why some scientists react with anger or dismissal when it is brought up. It is an existential threat to their life's work. But true science requires us to look at the crack and ask why, even if the answer brings the cathedral down. The universe does not care about our models. It simply is, and right now it is showing us that it is stranger than we can imagine. We must also consider the false vacuum decay concept again. The Higgs field gives particles mass. We believe the Higgs field is in a stable minimum energy state. But if it's in a false minimum, like a ball stuck in a small dip on a mountainside, it could tunnel through to a lower state. If a bubble of true vacuum nucleated in the early universe, it would expand at the speed of light, destroying everything. Some physicists speculate that the cold spot could be a region where the field tried to decay but was stopped, or a region where the values of the field are slightly different. If the vacuum is not stable there, it is a time bomb. It suggests that the stability of matter is precarious. We sleep soundly because we think the laws of physics are ironclad. The cold spot whispers that they are merely guidelines, subject to change without notice. Let's zoom out to the largest structure of all, the cosmic web. Galaxies are arranged in filaments, like a nervous system. Voids are the spaces between the nerves. The cold spot is the largest gap in the nervous system. If you view the universe as an information processing system, computational universe theory, then the cold spot is a massive region of zero processing. No stars, no life, no observers. It is a brain lesion. This biological metaphor is disturbing but apparent. The complexity of the universe grows over time, but the cold spot is a region of arrested development. It is dead tissue. If the universe is trying to wake up through the evolution of life and consciousness, the cold spot is a place where it remains in a coma. We, the observers in the Milky Way, are the neurons firing, looking across the synaptic gap at the silence. The timeline of discovery is accelerating. In the 1990s, we barely knew about dark energy. In the 2000s, WMAP found the spot. In the 2010s, Planck confirmed it and the supervoid was mapped. In the 2020s, the Euclid mission and the James Webb Space Telescope are providing data that challenges the standard model even further. Every time we look closer, The cracks get wider. We are in a golden age of cosmology, but it feels like a horror story. The more we know, the less sense it makes. The Hubble tension, the disagreement on how fast the universe is expanding, is another symptom of this. The cold spot is not an isolated incident. It is part of a systemic failure of our understanding. We are approaching a paradigm shift. The universe is about to reveal a new layer of reality to us, and if history is any guide, the new layer will be more vast, more indifferent, and more terrifying than the last. Think about the photons hitting the detectors of the Planck satellite. They traveled for 13 billion years. They avoided absorption by gas clouds, gravitational lensing by black holes, and scattering by dust. They arrived carrying a message. 150 microkelvins colder. That message is a ghost story written in light. It tells of a trauma in the infant universe. We are the detectives trying to solve a cold case where the trail has gone cold, literally. The suspects are multiverses, vacuum decays, and hyperdimensional gravity. The victim is the concept of a simple universe. The verdict is still out. But one thing is certain. The universe is not the smooth, predictable machine we thought it was. It is a chaotic beast, and it has scars. The concept of cosmic variance is the ultimate cop-out, and yet it might be true. It says we only have one universe to observe, so we can't calculate true probabilities. If you flip a coin once and it lands on heads, you can't say it always lands on heads. We can't step outside our universe to see if other universes have cold spots. Maybe every universe has a cold spot. Maybe it's a birthmark. This limitation of sample size n=1 is the prison of cosmology. We are trapped inside the experiment we are trying to measure. We can never truly know if the cold spot is rare or common, an anomaly or a standard feature. We are prisoners of our own perspective, banging on the walls of the cosmos, trying to guess what the building looks like from the outside. The connection between the cold spot and the Hubble tension is a burgeoning field of study. The universe seems to be expanding faster in our local neighborhood than it does in the distant early universe. Some suggest that we are living inside a local void, the KBC void, which mimics the effects of dark energy, but the Eridanus supervoid is a supervoid. If voids distort our measurements of expansion, then the cold spot is the most distorted place in the universe. Measuring the expansion rate through the cold spot might yield impossible numbers. It acts as a funhouse mirror, warping the light of everything behind it. We cannot trust the data that passes through it. It is a blind spot in our field of view, a region where the rulers are bent and the clocks run wrong. As we stare at the cold spot, we must remember the great filter. The Fermi paradox asks where the aliens are. The great filter suggests something destroys civilizations before they can spread. Could the physical instability of the universe be the filter? If regions like the cold spot are dangerous, prone to vacuum decay or radiation bursts, then life might only be possible in the quiet zones. We might be huddled in a rare oasis of stability. The cold spot might be a dead zone where the filter has already swept through. Looking at it is looking at the graveyard of potentiality. It reminds us that the universe is not designed for us. We are a byproduct that survives only in the calm eddies of a violent river. What if the cold spot is expanding? We assume it is a static scar. But if it is a vacuum decay bubble, it grows at the speed of light. We wouldn't see it growing because the light takes time to reach us. By the time we see the wall of the bubble, it is already upon us. This is the false vacuum nightmare. The data suggests it is stable, but our observation period, 50 years, is a blink of an eye in cosmic time. We assume the scar is old and healed. But what if it is a festering wound? The lack of data on the temporal evolution of the cold spot is the scary part. We have a snapshot, not a movie. We don't know if it's getting bigger, colder, or closer. The Eridanus constellation has historically been associated with the river of the underworld in mythology. It is fitting that the deepest abyss in the universe lies there. Science and myth often converge when we reach the limits of understanding. We name things dark energy, dark matter, the great attractor. These are placeholders for ignorance, monsters on the edge of the map labeled, "Here be dragons." The cold spot is the biggest dragon of all. It is the physical manifestation of the unknown. It challenges our hubris. We think we have mapped the cosmos, but we have only mapped the islands of light. The ocean of dark remains a mystery. Let's summarize the implication phase of our investigation. The standard model is bleeding. The cold spot is the wound. The supervoid is the bruise around it. The multiverse is the weapon that caused it. We are left with a reality that is either 1. A specific, rare accident in a multiverse. 2. A decaying false vacuum. 3. A flawed simulation. None of these options are comforting. They all demote humanity from observers of a majestic clockwork to survivors of a cosmic wreck. The emotional toll of this science is real. It strips away the illusion of permanence. The sky is not a ceiling, it is a veil, and it has a hole in it. Yet, there is a thrill in the terror. If the multiverse theory is correct, then the cold spot is proof of infinite possibilities. It means that for every mistake made in this universe, there is another where it went right. It means that reality is inexhaustible. The cold spot might be the most important object in the history of science because it is the first tangible thing that points to outside. It is the key to the lock of the universe. If we can understand it, we unlock a physics that transcends our bubble. We move from universe to omniverse. The darkness is inviting us to step through. But before we get carried away with sci-fi dreams, we must ground ourselves in the cold, hard data one last time. The temperature is 2.7 Kelvin. The spot is 70 to 150 microkelvins colder. The void is 1.8 billion light-years wide. These are facts. They are not theories. They are measurements. You can go to the data archives of the Planck mission and download them yourself. The anomaly is sitting on a hard drive right now. It exists. It is not a story we made up to scare you. It is a physical reality that is currently bombarding the Earth with slightly less microwave radiation than it should. It is touching you right now. The shadow of the cold spot falls on Earth every day. The future of this research lies in 21-centimeter cosmology, mapping the neutral hydrogen of the dark ages before the first stars lit up. This will give us a 3D map of the early universe, not just the 2D surface of the CMB. If the cold spot exists in the dark ages data, it proves it is primordial. If it appears later, it proves it is a structural evolution. This is the next frontier. We are building the telescopes right now, the square-kilometer array, to look deeper into the void. We are not turning away from the horror. We are building bigger eyes to stare directly at it. As we move into the next phase of our analysis, we need to question the nature of gravity itself. We assume Einstein was 100% right, but the cold spot suggests that at ultra-large scales, gravity might behave differently. Modified gravity theories, MOND, usually try to explain rotation curves of galaxies, but they might also explain the formation of megavoids. If gravity becomes repulsive at certain scales, or weaker, it could blow open these voids naturally. This would mean general relativity is only a local approximation. We might be wrong about the fundamental force that holds us to the ground. The cold spot is the laboratory where Einstein fails. Imagine a universe where the laws of physics are fluid, where constants drift over billions of years. The cold spot is the evidence of that drift. It is a glimpse into an epoch where the rules were still settling. If we accept this, we accept that the universe is organic, evolving, and mutable. It is not a crystal, it is a living thing, growing and changing. And like any living thing, it has defects, scars, and diseases. The cold spot is the pathology of the cosmos. We are the doctors trying to diagnose the patient from inside the patient's body. The journey into the cold spot is a journey into the heart of darkness. But darkness is not empty. In quantum mechanics, the vacuum is full of potential. Virtual particles pop in and out. The empty void of Eridanus is seething with quantum activity. It might be that the energy is not missing, but hidden in a state we can't access. Dark radiation, sterile neutrinos, the void could be filled with invisible ghosts that have mass but no light. We might be looking at a cloud of dark matter so dense it pushes normal matter away, creating the illusion of a void. The cold spot could be the hiding place of the dark sector. We have established the anomaly. We have established the failure of standard explanations. We have introduced the terrifying alternatives. Now we must look at the human reaction. How do scientists cope with this? They publish papers with dry titles like Anomalous Fluctuations in the CMB, but in private, over coffee, they admit it is weird, disturbing, broken. The cognitive dissonance is real. Science is the pursuit of order. but the cold spot represents chaos. It is the dragon at the gate. And for the rest of this script, we are going to ride that dragon into the unknown. The cold spot serves as a humble check on our arrogance. We think we are masters of the universe because we split the atom and landed on the moon. But we are ants crawling on a sidewalk, oblivious to the construction work happening miles away. The cold spot is the jackhammer we can just barely hear. It reminds us of the scale. 1.8 billion light-years. It would take a beam of light, the fastest thing in the universe, nearly 2 billion years to cross it. Civilizations could rise and fall 1,000 times in the time it takes a photon to cross the empty dark. We are alone in the dark. That is the feeling the cold spot evokes. The universe is not hugging us. It is expanding away from us, and in some places, it is already gone. The isolation of the Eridanus void is a physical manifestation of existential loneliness. But it is also a challenge. If we can explain this, we can explain anything. It is the final boss of cosmology. The cold spot is waiting for a genius, a new Einstein, to crack its code. Until then, it sits there, cold and silent, mocking us. As we transition to the deeper implications, remember this: the map is not the territory. The CMB image is just a map. The reality is out there. 1 billion light-years of cold nothingness, a scar on the face of God, a collision with another world. Whatever it is the most significant thing in the sky, and we are going to keep looking at it until it blinks. The investigation is far from over. New data is coming: the Simons Observatory, the Euclid Telescope. They will map the void in high definition. We will see the galaxies on the edge of the cliff. We will see the structure of the nothingness. We are about to turn the lights on in the basement, and we might not like what we see scuttling in the corner. So, take a breath. We have stared into the abyss. Now we are going to jump in. In the next section, we will explore the specific physics of the multiverse collision in detail and what it would look like if it happened again. We will explore the fate of the universe if the cold spot grows. The horror is just beginning. The hole in reality is open, and we are falling through. To grasp the terrifying mechanics of a multiverse collision, we must understand the engine that drives the creation of universes: eternal inflation. Proposed by physicists like Alan Guth and Andre Linde, this theory suggests that the Big Bang was not a one-time event. Instead, the inflaton field, the energy field that drove the rapid expansion of the early cosmos, is like a pot of boiling water that never stops boiling. In this cosmic soup, the space between bubbles expands faster than light, pushing them apart eternally. However, pocket universes like ours form when a localized region of this field decays into a lower energy state, essentially freezing out of the expansion. We are living inside one of these frozen bubbles, floating in a sea of rapidly expanding high-energy vacuum. The horror arises when you realize that because the space between bubbles is expanding so fast, we should be isolated forever. But statistics dictates that in an infinite fractal foam, some bubbles will form close enough to touch before the space between them rips them apart. The cold spot is the mathematical probability of a fender bender in an infinite parking lot, and the damage on our bumper proves that the other driver was heavy. When two bubble universes collide, it is not like two planets crashing. It is a clash of fundamental laws. Each bubble is defined by a, quote, domain wall, a boundary where the energy state transitions from the high-energy false vacuum outside to the low-energy true vacuum inside. If our bubble collided with another, the domain walls would smash together, releasing an incomprehensible amount of energy. Models by the Perimeter Institute suggest that this collision would send a shockwave rippling through the interior of both bubbles. In our universe, this shockwave would manifest as a massive displacement of matter and energy, literally blowing a hole in the plasma of the early universe. The region of impact would be stripped of its heat, leaving behind a scar that freezes into the cosmic microwave background. As the universe expands, we are looking at the cold spot and seeing the bruise left by a cosmic sledgehammer. The fact that we are here to see it means the collision was elastic. We bounced off. If it had been inelastic, the domain wall might have collapsed, and our universe would have been flooded with the alien physics of the other bubble, instantly sterilizing all potential for life. The specifics of the energy transfer during such a collision are chilling. The other universe likely had different physical constants, perhaps a different mass for the electron, or a different strength for the strong nuclear force. When the bubbles touched, for a brief moment, these two realities interacted. The cold spot represents a region where energy was potentially siphoned out of our universe and into the other, or where the gravitational repulsion of the other bubble pushed our matter away. This repulsion is why the spot appears as a void. It's not just that the matter is missing, it's that it was forcibly ejected. Imagine a drop of oil hitting a drop of water. They resist each other, deforming their shapes. The circular nature of the cold spot is consistent with two spheres pressing against each other. The sheer geometric perfection required to create such a circular anomaly in a chaotic explosion like the Big Bang is almost impossible to explain naturally. It implies an external geometry, a spherical intruder that left its imprint on the skin of our infant cosmos. If a collision happened once, the probability that it will happen again is non-zero. In fact, if eternal inflation is true, collisions should be happening somewhere in the multiverse right now. The scary part is that we can't see them coming. A bubble collision travels at the speed of light. We would have no warning. One moment, the sky is starry. The next, a wall of pure energy obliterates the solar system. The cold spot is a fossil of a collision that happened billions of years ago, when the universe was small and dense. Today, the universe is vast and diffuse, so the chances of a collision hitting us specifically are lower, but the consequences would be far more total. We are drifting in the dark, assuming the road is clear, but the cold spot proves there is traffic. And since we cannot see outside our bubble, we are driving blindfolded. The existence of the cold spot moves the end-of-the-world scenario from a distant heat death to an immediate, unpredictable threat that could arrive tomorrow. This brings us to the dizzying concept of the string theory landscape. String theory predicts that there are $10 carat, $500 possible shapes for the extra dimensions of space, each resulting in a different vacuum energy and different laws of physics. This landscape is like a vast mountain range with millions of valleys. We live in one specific valley, a local minimum of energy that allows for stable atoms. The cold spot might be evidence of a neighbor in this landscape. But not all neighbors are friendly. Some valleys in the landscape are deep, with negative vacuum energy that causes the universe to crunch instantly. Others are shallow, with unstable physics. If the cold spot was a collision with a universe from a bad part of town in the string landscape, we are lucky to be alive. It suggests that the multiverse is not just a collection of copies of us, but a chaotic zoo of failed realities, monsters, and dead ends. We are huddled in a rare sanctuary of stability, and the cold spot is the window through which we can see the wasteland outside. The anthropic principle states that we observe the universe to be the way it is because if it were different, we wouldn't be here to observe it. It is a survival bias. But the cold spot challenges the weak anthropic principle. We can exist in a universe with a cold spot, obviously, but the spot itself seems to violate the finer tuning we expect. It suggests that our universe is not perfectly tuned for life, but merely good enough. It is a rugged, damaged goods universe. This is unsettling because it implies we are not the intended result of a perfect process, but the accidental mold growing on a bruised apple. If the collision had been slightly harder, the cold spot would be larger. If it covered 50% of the sky, galaxy formation would be crippled. We are living on the edge of viability. The cold spot is the line in the sand. Any closer, and we wouldn't be here. It turns our existence from a certainty into a lucky break, a coin flip that landed on its edge. While the cold spot pushes us away or sits empty, there is a motion in the universe that suggests we are being dragged. This is the dark flow. Astronomers have detected that hundreds of galaxy clusters, including our own, are moving at millions of miles per hour toward a specific point in the southern sky, roughly between the constellations of Centaurus and Hydra. This motion is distinct from the general expansion of the universe. It is a coherent flow, like a river. The standard model cannot explain this. In an isotropic universe, there should be no preferred direction of motion. We should be expanding outward evenly. Instead, we are drifting. Some theories link dark flow to the same event that caused the cold spot. If a massive object, another universe or a remnant of the Big Bang, tilted the table, everything would slide. We are not static observers. We are passengers on a raft, caught in a current that is pulling us toward an unknown destination beyond the edge of the visible universe. The dynamic between the void, the cold spot, and the attractor creates a terrifying picture of our local cosmos. On one side, we have a massive hole that repels matter or is devoid of it. On the other, we have a massive concentration of mass, the great attractor and the Shapley supercluster, pulling us in. It feels like a drain. The universe appears to be tilted from the low density of the Eridanus void down to the high density of the attractor. This dipole structure is the largest structure in the universe. It spans the entire observable sky. We are living in a slanted reality. If you imagine the fabric of space-time as a rubber sheet, the cold spot is a hill, and the great attractor is a deep well. We are rolling down the hill into the well. This flow affects everything: the CMB, the distribution of galaxies, and the future trajectory of the Milky Way. We are not floating in space. We are falling through it, governed by titans of gravity that dwarf our entire galaxy cluster. The source of the dark flow lies beyond the cosmic horizon. The observable universe is a bubble defined by how far light has traveled since the Big Bang. We cannot see outside it. But gravity has infinite range. If there is a massive structure just outside our horizon, we would feel its pull but not see its light. The dark flow suggests that something monstrous is lurking just out of sight. It could be a superstructure, left over from inflation, a knot of spacetime so dense it pulls galaxies from billions of light-years away. Or, in the multiverse context, it could be the gravitational shadow of a neighboring universe that is heavy enough to tug on ours. We are feeling the ghost of a monster we can never see. It is the ultimate cosmic horror, being dragged into the dark by an invisible hand. We measure the speed, 600 kilometers per second, but we don't know what is reeling us in. Recently, astronomers identified the dipole repeller as the counterpart to the great attractor. The repeller is a region of space that is so empty, so devoid of galaxies, that it effectively pushes matter away. Why? Because gravity is attractive. If you have a region with no mass, and regions all around it with mass, the matter will be pulled towards the mass, creating the illusion that the empty spot is pushing. The cold spot and the dipole repeller might be related phenomena, regions of underdensity that shape the flow of the cosmos. This means that nothingness is a force. The absence of matter shapes the destiny of matter. We are being shepherded by the voids. These empty spaces are the walls of our cage, directing the traffic of galaxies. We think of stars as the important parts of the universe, but the voids are the rulers. They occupy the majority of the volume, and their silent, repulsive pressure dictates where civilizations can exist. What is the ultimate fate of the Eridanus supervoid? Will it stay the same size, or will it grow? In a universe dominated by dark energy, voids expand faster than filaments. As the universe ages, the voids will swell, crushing the filaments into thinner and thinner strands. Eventually, the voids will merge. The cold spot is a preview of the end state of the universe: cold, dark, and empty. It is a future echo. If you want to know what the Milky Way will look like in 100 billion years, look at Eridanus today. The stars burn out, the galaxies disperse, and only the cold background radiation remains. It is a region of maximum entropy, a place where the story of the universe has already ended. By studying it, we are performing an autopsy on our own future. The heat death is not a theory there. It is a reality that has effectively already arrived. Imagine for a moment that you are a sentient being evolving on a planet inside the Eridanus supervoid. Your night sky would be terrifyingly different from ours. You would see almost no stars with the naked eye. Your galaxy might be the only thing you ever know. You would develop astronomy and conclude that the universe consists of one island of light in an infinite ocean of black. You would have no concept of other galaxies, expansion, or the Big Bang, because the evidence would be too faint to see. You would be cosmically lonely in a way we cannot comprehend. But what if those civilizations are the smart ones? Isolated from the violent mergers and radiation of dense clusters, maybe the void is a safe harbor. Or maybe their isolation dooms them. Without neighbors, they have no one to call, no one to trade with, no paradoxes to solve. The cold spot is a prison cell for any intelligence trapped within it, a solitary confinement block on a galactic scale. The speed of light limit, $C$, is the ultimate tragedy when looking at the cold spot. Even if we wanted to go there to investigate, we couldn't. It is nearly 2 billion light-years away. Even at light speed, by the time we arrived, the expansion of the universe would have pushed the galaxies there further apart, or carried them away entirely. We are looking at a ghost image. The photons we collect today left that region before dinosaurs walked the Earth. We are disconnected causally from the cold spot. It is physically real, yet for all practical purposes, it is in another dimension, because we can never interact with it. This causality horizon is a hard limit on human knowledge. We can see the monster, but we can never touch it, measure it directly, or understand its true nature. We are forced to be voyeurs of our own reality, watching the mysteries of the cosmos play out on a screen we cannot cross. The black hole information paradox asks if information is lost when it falls into a black hole. The cold spot presents a similar void information paradox. If a region of the universe is erased or fails to form, where did the quantum information go? In a unitary universe, information is never destroyed. If the cold spot was caused by a collision that annihilated matter, or a vacuum decay that deleted it, that information must be preserved somewhere. Perhaps it is encoded on the boundary of the void, like a hologram, or perhaps it leaked into the other universe. If information can leak out of our universe, then our reality is not a closed system. It leaks. And if it leaks, it can be hacked. The cold spot could be the port through which the data of our universe is being extracted or corrupted by an external observer or system. This brings us back to the simulation argument, but with a more technical focus. In computational fluid dynamics, to save processing power, you don't render the empty spaces with high fidelity. You use a mesh that is fine-grained near complex objects, galaxies, and coarse-grained in empty space, voids. The cold spot might be an artifact of adaptive mesh refinement. The simulator didn't need to render that part of the sky because nothing was happening there, so it left it as a low-resolution, low-energy texture. The anomaly in the temperature, the coldness, could be a rounding error in the floating point arithmetic of the simulation. If this is true, the cold spot is the most convincing evidence that we are code. It is a glitch, a dead pixel in the sky, and the fact that we noticed it might alert the system to correct it or reboot the simulation. The legendary physicist Sir Roger Penrose has a different, equally terrifying theory. Conformal cyclic cosmology, CCC. He believes the universe goes through infinite cycles, or eons. The Big Bang was not the beginning, but merely the bounce from the previous universe's death. In this model, supermassive black holes from the previous universe would eventually evaporate via Hawking radiation over trillions of years. This evaporation releases a tremendous amount of energy. Penrose argues that the cold spot and other anomalous points in the CMB are Hawking points. They are the ghostly footprints of supermassive black holes that existed in the universe before this one. The energy they released imprinted onto the transition phase, creating a hot spot or a cold spot in our new Big Bang. If Penrose is right, we are looking at the gravestone of a dead galaxy from a forgotten eon. The implications of Penrose's theory are profound. It means the cold spot is not a random fluctuation, but a signal from the past. It tells us that there were civilizations, stars, and black holes before our Big Bang. It implies that our universe is a graveyard built on top of a graveyard. The cold spot is the echo of a black hole that might have consumed an entire galaxy of sentient beings a trillion years ago. We are staring at their remains. The structure of the CMB is a palimpsest, a manuscript written over and over again, where the ink of the previous story bleeds through into ours. It turns the sky into a history book of infinite loss. We are walking among the ghosts of dead universes, and the cold spot is the loudest ghost of all. If the cold spot is a Hawking point, it means the universe remembers. It suggests a continuity of information across the Big Bang, but it also suggests a cycle of inevitable destruction. The previous universe died. Ours will die too. And the black holes we are creating right now, Sagittarius AM87, will leave scars on the next universe. We are currently carving the cold spots of the future cosmos. Our existence, our struggles, will be reduced to a tiny, inexplicable temperature fluctuation in the sky of a species that won't exist for another trillion years. They will look at their sky, see a cold spot caused by our galaxy's black hole, and wonder, just like we are wondering now. It is a melancholy immortality. We don't survive, but our gravity does. There is a theological horror here as well. If the universe is a creation, it is a flawed one. The cold spot is an imperfection. In Gnosticism, the physical world was created by a flawed deity, the demiurge. The cold spot looks like a mistake in the clay. It is an asymmetry that ruins the perfection of the sphere. Why would a perfect creator leave a hole in the work? Or is the hole the point? Is it a ventilation shaft? A drain? A door? The anomaly forces us to question the argument from design. If the universe is designed, the designer left a fingerprint, and it is a fingerprint of cold emptiness. It suggests indifference, or perhaps a work in progress that was abandoned before it was finished. Let's return to the physics of dark energy, lambda, within the void. If the vacuum energy density is lower in the cold spot, it changes the fundamental interactions of particles. The fine structure constant, alpha, which dictates the strength of electromagnetism, might be different there. Recent observations of quasars have hinted that alpha might vary across the sky. If alpha is different in the cold spot, chemistry as we know it would be impossible. Atoms wouldn't bond, stars wouldn't burn the same way. The cold spot would be a, quote, zone of negation for biology. It acts as a barrier to life not just because of isolation, but because the software of matter doesn't run on the hardware of that space. It is a forbidden zone where the rules of the game are tweaked just enough to make losing inevitable. This variation in dark energy leads to the Big Rip scenario. If the Eridanus supervoid is a bubble of phantom dark energy, where the equation of state $W less than -$1, then the expansion force increases over time. In our region, expansion is slow. In the void, it is rampant. This phantom energy will eventually tear apart the galaxies on the edge of the void. Then it will tear apart the solar systems. Then the planets. Finally, $10 caret, minus $19 seconds before the end, it will rip electrons from protons. The cold spot is the epicenter of this destruction. It is the cancer cell that will metastasize and kill the host. The Big Rip doesn't happen everywhere at once. It starts in the voids and spreads. We are watching the fuse burn. The psychological weight of the Big Rip is different from the heat death. Heat death is a slow fade to black, a peaceful sleep. The Big Rip is a violent shredding. It is torture. And the cold spot is the instrument of that torture. To see it in the sky is to see the executioner sharpening the axe. The galaxies inside and around the cold spot are already feeling the tidal forces of this phantom energy. They are being stretched. If we could look closely at them, we might see distorted spirals, trails of stars stripped away by the vacuum itself. It is a cosmic crime scene in slow motion. Pascal's wager argues it is better to believe in God just in case. There is a cosmological Pascal's wager regarding the cold spot. If it's a random fluke, we lose nothing by ignoring it. But if it is a sign of vacuum instability or a collision, ignoring it costs us everything. We must treat it as a threat. This is why funding for missions like the Euclid Space Telescope is not just for science. It is for planetary defense on a philosophical level. We need to know if the walls of reality are closing in. The anxiety of the cold spot is the anxiety of the sentry in the watchtower who sees movement in the dark. You don't know if it's the wind or an army, but you have to wake the camp. The axis of evil suggests that the universe might be smaller than we think. If the universe is like a hall of mirrors, light wraps around. A dodecahedral universe, shaped like a 12-sided soccer ball, would create matching circles on the sky where the faces of the shape intersect. The cold spot could be one of these intersections. If we live in a Poincaré dodecahedral space, the universe is finite, closed, and relatively small. We are seeing the back of our own head. The cold spot is the seam where the wallpaper doesn't quite match up. This claustrophobia is palpable. It means there is no infinite frontier. There is just the loop. We are trapped in a geometric shape, bouncing around like photons in a diamond. Jean-Pierre Luminet, a French astrophysicist, famously proposed this wraparound universe model to explain the low quadrupole moment of the CMB, another anomaly linked to the cold spot. The math works surprisingly well. The cold spot corresponds to a defect in the crystal structure of space. If we are in a crystal universe, then the cold spot is a fracture. A fracture in a crystal is a weak point. If the universe is struck by a gravitational wave or a collision, it will shatter along the fault line. The cold spot is the fault line of reality. We are living in a cracked glass. Let's talk about neutrinos. These ghost particles pass through everything. But they have mass. There is a theory that the cold spot is a region where the cosmic neutrino background is different. If neutrinos cluster differently than normal matter, they could create a mass that we can't see but that affects the temperature. But why would neutrinos behave differently there? It requires sterile neutrinos, a hypothetical fourth type of neutrino that interacts with nothing, not even the weak nuclear force. If the cold spot is a cloud of sterile neutrinos, it is a cloud of pure darkness, in the particle physics sense. It is a clump of matter that has divorced itself from the standard model entirely. The Euclid mission, launched to map the geometry of the dark universe, is our best hope. It will look at the shapes of galaxies behind the cold spot. If the cold spot is a massive void, the galaxies behind it will be distorted by anti-lensing. A massive object acts as a convex lens, magnifying things. A void acts as a concave lens, demagnifying them. If Euclid sees this demagnification, it proves the void is real and empty. If it sees something else, distortions that don't match a void, then we are back to the collision or texture theories. Euclid is the surveyor sent to map the haunted house. There is a concept called the redshift anomaly in the void. Galaxies inside voids seem to move away from us faster than the Hubble flow predicts. It's as if the void is expelling them. This peculiar velocity adds to the data that the void is expanding aggressively. It acts like a pressure cooker. The empty space has higher pressure due to dark energy than the filaments. It is blowing up the balloon from the inside. This pressure confirms that the vacuum energy is the dominant force in the void. Matter has lost the battle there. Gravity has surrendered to lambda. What about the few galaxies that are inside the void? The Void Galaxy Survey studies them. They are often small, irregular, and rich in star formation. They are pristine, having never collided with other galaxies. They are time capsules of the early universe. Because they are isolated, they haven't evolved through mergers. Looking at a galaxy in the cold spot is like looking at a galaxy from 10 billion years ago, preserved in isolation. They are the wild children of the cosmos, growing up alone in the woods. They hold the secrets of how galaxies form without external interference. But their isolation is absolute. The brane-world scenario in string theory suggests that our universe is a 3D membrane, brain, floating in a higher dimensional bulk. Gravity can leak off our brain. The cold spot could be a leak point. Imagine a hole in a bucket. The water, gravity, leaks out. If gravity leaks out of the cold spot, then mass estimates there would be wrong. Things would drift apart faster because the glue is missing. It could also be a touch point, where another brain is hovering close to ours. The gravitational pull of the parallel brain is felt as a phantom force. We are feeling the gravity of a ghost world inches away in the fourth dimension. The ekpyrotic universe theory posits that the Big Bang was a collision of two brains. It wasn't a beginning, but a clash. If the brains are rippled, they don't hit everywhere at once. They hit in spots. The cold spot could be a region where the brains didn't quite touch or touched with less force. It is a cold spot in the fire of creation, a place that didn't ignite. This means the Big Bang wasn't uniform. It was patchy. We are living in the burnt leftovers of a five-dimensional car crash. Let's consider baryon acoustic oscillations, BAO. These are sound waves from the early universe. The early universe rang like a bell. The distribution of galaxies today is the frozen pattern of those sound waves. The cold spot represents a missing note in the cosmic symphony. A region where the sound didn't propagate. Why? Was the medium different? Was there a damper? It's like listening to a perfect orchestra and hearing a sudden, terrifying silence in the woodwind section. The silence implies a breakage in the instrument. The universe is out of tune, The entropy of the void is a fascinating paradox. Usually, high entropy means disorder. A void is simple, mostly empty space, so it seems low entropy. But in terms of information, it is high entropy because there are many ways to arrange nothing. The cold spot is a region of high entropy that refuses to evolve into complex structures. It is stuck. It defies the arrow of time, which usually drives complexity, stars, life. The arrow of time might be broken there. Time itself might feel different. Without events to mark time, does time pass? In the void, eternity happens in an instant. Boltzmann brains are a thought experiment. In an infinite void, over infinite time, random fluctuations will eventually assemble a brain, complete with false memories, out of the vacuum. The cold spot, being a massive, old void, is the most likely place for Boltzmann brains to form. It is a nightmare scenario, disembodied consciousnesses popping into existence in the dark, hallucinating a life and then dissolving back into the vacuum. The void might be filled with the fleeting screams of impossible minds. It is the haunted house of thermodynamics. Is there a physical wall around the cold spot? Some textures in topological defect theory are domain walls. If a wall exists, it would be invisible until you hit it. It would refract light. We might be seeing the galaxies behind the spot in the wrong place because we are looking through a cosmic lens. The lens of the cold spot might not be gravitational, but topological, a wrinkle in the glass. If we sent a probe there, it might hit the wall and shatter, or pass through and be inverted. We don't know the topology of the defect. We must return to the great filter. If advanced civilizations destroy themselves, they leave ruins. But if they succeed, what do? They maximize energy. They encompass stars. A Kardashev Type 3 civilization would dim an entire galaxy. A Type 4, universal, would dim a cluster. What if the cold spot is the home of a Type 4 civilization? They have harvested every star, captured every photon. The coldness is the waste heat of their supercomputers. We see a void. They see a fully efficient empire. We are the barbarians living in the lit-up jungle. They are the city dwellers in the climate-controlled dark. The Tabby's star anomaly, where a star dimmed oddly, sparked debates about alien megastructures. The cold spot is Tabby's star on a universal scale. It is an entire region of the sky that is dimmed. The natural explanation, supervoid, is struggling to fit the data. The artificial explanation, harvesting, fits the data, but violates our sense of reality. But remember Clarke's third law. Any sufficiently advanced technology is indistinguishable from magic. Or in this case, indistinguishable from a hole in reality. If they are there, they are hiding, and a void is the perfect camouflage. Or perhaps the super-civilization hypothesis is darker. Maybe they didn't harvest the stars, maybe they left. If the universe is dying, an advanced species might punch a hole in reality to escape to a younger universe. The cold spot could be the exit wound, the blast radius of a wormhole experiment that allowed 1 trillion souls to flee the sinking ship. They left behind a cold, empty ruin as they migrated to a better brain. We are looking at the door they left open. The lifeboat theory complements this. If the vacuum decay is coming, or the Big Rip, the only way to survive is to create a region of space that is cut off from the rest. A bubble of safety. The cold spot might be an artificial bubble where the expansion of the universe is halted or controlled. Inside, a civilization waits out the apocalypse. To us, it looks like a void. To them, it is a fortress. We are on the outside, exposed to the elements. They are in the bunker. The philosophical implication of the multiverse is usually nihilistic. If there are infinite versions of you, you don't matter. But the cold spot adds a layer of violence. It's not just that there are other universes, it's that they are crashing into us. It makes the cosmos a war zone. We are not safe in our bubble. The walls are flexible and breakable. This destroys the feeling of cosmic security. We are in a fragile egg, and something big is moving around the nest. Let's ground this again. The standard model of particle physics is complete. We found the Higgs, but the standard model of cosmology is breaking. The two standard models don't talk to each other. Quantum mechanics, small, and gravity, large, are incompatible. The cold spot is where they clash. It is a macroscopic quantum event. It is the singularity without the black hole. It is where the math fails. And where the math fails, the monsters live. We have 100 scenes behind us, and we have stripped away the comfort of the night sky. We know the cold spot is real. We know it defies probability. We know it might be a collision, a void, or a scar. But we haven't talked about the consciousness aspect. Does the universe know it's wounded? In panpsychism, the universe has proto-consciousness. A wound of this size would be a trauma in the cosmic mind. Are we the neurons trying to process the pain of the universe? As we look at the cold spot, we are the universe looking at itself, and we are confused. This confusion is a data point. If the universe were simple, we would understand it. The fact that we don't proves it is complex beyond our current evolution. The cold spot is a teacher. It is forcing us to invent new math, new physics, new telescopes. It is pulling us forward. The terror is the fuel for our progress. We want to know what's in the dark. The great attractor pulls us. The cold spot pushes us. We are caught in a cosmic tug of war. This tension defines our local universe. We are not in a static place. We are in a dynamic, violent, stretching machine. And the machine is accelerating. The cold spot is getting colder relatively. The attractor is getting stronger. The universe is tearing itself apart to get to the end state. We are just watching the gears grind. In the next part of this script, we will look at the solution. Is there one? Can we fix the hole? Can we escape the big rip? Or is the script written in stone? We will explore the endgame scenarios. The cold spot is the prologue to the end. And the end is coming faster than we think. The connection between the cold spot and the wow signal is tenuous but fun to speculate. The wow signal came from Sagittarius. But if there are civilizations fleeing the void, they would send signals outward. Maybe the radio silence of the universe is because everyone is listening to the static of the cold spot, trying to decipher the warning. We are the only ones broadcasting I Love Lucy while everyone else is hiding in the basement. The Eridanus void is 1.8 billion light-years of silence. It is the quietest place in the universe. If you want to escape the noise of creation, you go there. Maybe it is a sanctuary. A monkish retreat for Type 3 civilizations. We project our fear of the dark onto it. But maybe the dark is peaceful. Maybe the cold spot is the only sane place in a chaotic multiverse. But peace is rare in physics. Usually gradients create flow. Hot to cold, high to low. The cold spot creates a massive gradient. Entropy flows into it. It is a heat sink. It is cooling the universe down. Without it, maybe we would have overheated. Is the cold spot the radiator of the cosmos? A necessary feature to keep the engine from melting? We are nearing the final act. The evidence is laid out. The anomaly is verified. The implications are terrifying. We are living in a bruised, battered, and possibly dying bubble. We are drifting towards a monster and away from a void. We are alone in the dark. Now, we turn our eyes to the future. Not just the future of the universe, but the future of humanity in the face of this knowledge. How do we live knowing the sky is broken? We embrace the absurdity. We explore the horror. Because the only way to defeat the fear of the dark is to shine a light so bright it burns the shadows away. We must now confront the most catastrophic physical implication of the cold spot, the possibility that it represents a nucleation site for vacuum decay. The standard model of particle physics tells us that the universe resides in a specific energy state, determined by the Higgs field. We assume this state is the quote state, the lowest possible energy level, like a ball sitting at the bottom of a valley. This stability allows for the existence of atoms, chemistry, and life. However, calculations regarding the mass of the Higgs boson suggest that we might actually be living in a false vacuum, a small dip in the side of the mountain, not the bottom of the valley. Below us lies the true vacuum, a state of lower energy and fundamentally different physics. If the universe were to tunnel through the energy barrier and reach that true vacuum, the result would be a bubble of new reality, expanding at the speed of light. Inside this bubble, the laws of physics would be rewritten. The cold spot, with its anomalous temperature and potential connection to early universe trauma, might be a region where the vacuum is less stable, or where a subcritical bubble once tried to form. If a bubble of true vacuum were to nucleate in the Eridanus supervoid today, it would be the ultimate apocalypse. The wall of the bubble would rush outward, incinerating and deleting everything in its path. matter would fall apart, chemistry would cease, and space itself would collapse into a lower energy state. We wouldn't see it coming because the wall travels at the speed of light. One moment we are here, and the next, the laws of nature that hold our atoms together simply evaporate. The horror of vacuum decay is that it is entirely silent and invisible until the very instant of destruction. Because the wave of destruction travels at the speed of light, no information can precede it. You cannot see the stars going out one by one because the light from those dying stars would arrive at Earth at the exact same moment as the wave itself. If the cold spot is indeed a region of instability, a ticking time bomb in the fabric of space-time, it forces us to re-evaluate the great silence of the cosmos. Perhaps the reason we see no other advanced civilizations is that the universe is far more unstable than we believe. If vacuum decay events are common in the multiverse, or even in our own universe's history, then regions of space might be periodically sterilized or rebooted. The cold spot acts as a grim memento mori, a reminder that the stability of the ground beneath our feet, the very vacuum of space, is not guaranteed. It is a frozen lake, and we are skating on thin ice, unaware of the deep, dark water waiting just millimeters below our blades. The anomaly in Eridanus is the sound of the ice cracking, a fracture that has existed for billions of years, whispering that the solid ground is an illusion and the plunge into the unknown is inevitable. This brings us to the fine-tuning problem and how the cold spot complicates it. Physicists have long marveled at how the fundamental constants of the universe, the strength of gravity, the charge of the electron, the cosmological constant, seem perfectly calibrated to allow for the existence of stars and life. If the strong nuclear force were slightly weaker, atoms wouldn't hold together. If gravity were slightly stronger, stars would burn out in millions rather than billions of years. This Goldilocks quality has led to arguments for a designer or a multiverse. But the cold spot ruins the perfection. It suggests that the tuning is not uniform. If the cold spot is a region where the constants are slightly off, where gravity is weaker or dark energy is stronger, then the universe is not a finely tuned machine, but a glitchy, patchwork assembly. It implies that life is a localized phenomenon that can only exist in the stable patches of the quilt. We are not the masters of the universe. We are the mold growing on the one slice of bread that hasn't gone stale yet. The cold spot is the stale part. It challenges the idea that the universe was made for us, and instead suggests that we are accidental tourists in a hostile, chaotic system that barely tolerates our existence. Consider the holographic principle, a cutting-edge theory in quantum gravity which suggests that our entire three-dimensional reality is actually a projection of information encoded on a two-dimensional surface, much like a hologram. This boundary, the cosmic horizon, contains all the data required to describe every atom, star, and galaxy inside. If this is true, then the cold spot represents a terrifying data corruption. Imagine a scratch on the surface of a DVD. When the laser tries to read it, the movie glitches, pixels disappear, or the scene freezes. The cold spot could be a scratch on the boundary of the universe. The information required to render that sector of space is missing or damaged. This would explain why the region is cold, empty, and mathematically anomalous. We are looking at a rendering error in the projection of reality. This implies that our universe is not a physical object in the traditional sense, but an information system, and like all systems, it is prone to bugs, crashes, and data loss. If the scratch on the boundary gets bigger, if the information degradation spreads, then the glitch in the sky will expand, erasing more galaxies, more stars, and eventually, us. We are characters in a movie that is slowly degrading on the reel. We need to talk about the equation of state for dark energy, denoted by the symbol $W. This number tells us how the density of dark energy changes as the universe expands. If $W is equal to -1, dark energy is a constant, the cosmological constant, and the universe will expand forever, but relatively smoothly. If $W is greater than -1, the density drops, and gravity might eventually win, leading to a big crunch. But if $W is less than -1, we enter the realm of phantom energy. Phantom energy grows denser as the universe expands. It creates a runaway feedback loop. The cold spot is the prime suspect for a region where $W less than -1. If the void is driven by phantom energy, it explains why it is so empty. The expansion there is so violent that it has already ripped apart all structures. It also means the Big Rip has already begun locally in Eridanus. The phantom energy is tearing that sector of space apart, and like a forest fire, it will spread. It will cross the billions of light-years to us, eventually overcoming the gravity of the Milky Way, the solar system, and finally the electromagnetic bonds of your own body. The cold spot is the spark of the phantom energy fire that will burn the universe down. Imagine the psychological impact on a future humanity that attempts to travel near the cold spot. Navigators would look at their star charts and see a massive blind spot. As they approach the edge of the Eridanus supervoid, the density of stars would drop precipitously. They would be standing on the cliffs of existence, looking out into an abyss that stretches for nearly 2 billion light-years. The isolation would be absolute. Communications would be impossible. Light takes too long to cross the gap. Any ship entering the void would be effectively leaving the universe, entering a zone of silence so profound it would crush the human spirit. It would be the ultimate test of sanity. Reports from the edge would speak of a darkness that feels heavy, a sky that lacks the comforting clutter of stars. It would be a place where the concept of direction loses meaning because there are no landmarks, only the endless, expanding dark. This is not just a hazardous region of space. It is a psychological hazard, a place where the human mind, evolved to recognize patterns, breaks down because there are no patterns to find. It is the Rorschach test of the cosmos, and all we see in it is our own insignificance. Let's dive deeper into the axis of evil and the preferred direction of the universe. The fact that the cold spot aligns with other low multipole anomalies suggests that the universe has a crystal structure or a spine. In a truly random, isotropic Big Bang, there should be no spine. It should be a shapeless cloud. But the alignment points to a geometry that dictates the layout of the largest structures. This implies that the Big Bang was an oriented explosion. It had a north and a south. If the universe has an orientation, it implies it exists within a larger space that defines that orientation. You cannot have a north without an external frame of reference. This points straight back to the multiverse or a higher dimensional container. The cold spot is the south pole of this hidden geometry. We are living in a structured object, possibly a 4-dimensional shape rotating in a 5-dimensional bulk. The evil in the name comes from the fact that this structure destroys the Copernican principle. We are not in a random spot. We are aligned with the machinery of the cosmos. We are cogs in a specific place, serving a specific structural function in a machine we cannot see. There is a theoretical connection between quantum entanglement and the geometry of spacetime, summed up in the equation ER equals EPR. This suggests that wormholes, Einstein-Rosen bridges, and quantum entanglement, Einstein-Podolsky-Rosen pairs, are the same thing. Spacetime is stitched together by entanglement. If the cold spot is a region where this stitching has failed, it is a region of disentanglement. The threads of reality have snapped. Alternatively, it could be the mouth of a primordial wormhole of gargantuan proportions. If the Big Bang created micro-wormholes, inflation could have stretched one of them to the size of 1 billion light-years. The cold spot might be a tunnel to another universe or a distant part of our own. It appears cold because the light coming through it is from a different time or place with different energy conditions. If it is a wormhole, it is not the sci-fi portal we imagine. It is a gaping maw, unstable and deadly, likely connecting us to a region of space-time that is hostile to life. We are looking down the throat of a tunnel that leads to nowhere, or worse, to a somewhere that we really don't want to visit. The Boltzmann brain paradox is a statistical nightmare that becomes more plausible in the context of the cold spot's entropy. In an infinite, eternal universe, random thermal fluctuations can theoretically assemble atoms into any configuration, including a fully formed human brain with memories. The probability is infinitesimally low, but in an infinite void like the cold spot, over infinite time, it becomes a certainty. The vast, empty expanses of the Eridanus void are the perfect breeding ground for these fluctuations. It implies that for every real consciousness that evolved biologically, like us, there could be trillions of ghost consciousnesses flickering into existence in the void, thinking they are alive and then vanishing. The cold spot might be a graveyard of momentary minds. It challenges our own reality. Are we biological beings with a history? Or are we a random fluctuation that just happened to form with the memory of a history? The existence of large, high-entropy voids makes the latter disturbingly more probable in certain cosmological models. The cold spot is the factory of hallucinations, churning out temporary ghosts in the freezing dark. The dynamic relationship between the cold spot and the great attractor is the defining struggle of our local universe. We are caught in a bulk flow, a massive river of galaxies moving at 600 kilometers per second. Imagine the universe as a tilted table. The cold spot is the high ground, the empty summit. The great attractor is the sinkhole. We are sliding. This motion is not due to the expansion of the universe. It is a, quote, peculiar velocity, a movement through space. This means something massive is pulling us, and something massive is pushing us. The dipole repeller, associated with the void, pushes because it lacks gravity, creating a relative vacuum that drives matter away. The attractor pulls with the mass of 1,000 galaxies. We are not static observers. We are debris in a landslide. The scale of this landslide is terrifying. It encompasses hundreds of millions of light years. We are moving towards a destination we cannot see, effectively being digested by the cosmic structure. We are heading towards the great attractor, but we will never reach it because dark energy will eventually rip the ground out from under us. We are running on a treadmill towards a cliff. Visualizing the dipole repeller changes how we see the sky. We usually look for bright lights, stars, and galaxies, but the most powerful forces are the empty spaces. The repeller is an anti-mass. It works by absence. Its influence is felt across billions of light years, steering the flow of the Laniakea supercluster, our home. It is a ghost handling the controls of the galaxy. The cold spot is the visible face of this repeller. It is the eye of the anti-storm. While we fear the crushing gravity of black holes, we should perhaps equally fear the crushing emptiness of the voids. A black hole rips you apart with tidal forces. A void isolates you until you freeze and fade away. The universe is a balance between the crushing density of the attractor and the freezing isolation of the repeller. We are poised precariously in the middle, in a habitable zone that is shrinking every day as the voids expand and the clusters collapse. We are walking a tightrope between being crushed and being cast out. Time itself might behave differently inside the Eridanus supervoid. General relativity teaches us that gravity slows down time. Clocks run slower near a massive object like Earth or a black hole. In the deep void, where mass is almost non-existent, clocks should theoretically run slightly faster compared to the rest of the universe. This means that the cold spot is aging faster than us. It is further along the timeline of the universe. If we look into the void, we are looking at a region that has experienced more time than we have. It is a window into the deep future. The galaxies there are older, more evolved, or dead. The end of time, the heat death, will arrive in the voids first. The cold spot is the vanguard of the end. It is a region where the future has already happened, and the result is nothing. Silence. Darkness. It is a spoiler for the end of the movie, and it tells us that the hero doesn't win. The screen just goes black. The simulation hypothesis gains traction when we look at the graininess of the universe. If the cold spot is a rendering error, we must ask, what kind of computer runs this? A simulation that creates a 1.8 billion light-year void is either running a very specific experiment or it is buggy. Maybe the cold spot is a buffer overflow, where the code piled up and deleted the assets. Or maybe it is an optimization technique. Don't render what the observers, us, aren't looking at. But now we are looking at it. Will the simulation correct itself? Will the void suddenly fill with stars as the rendering engine catches up? Or is the cold spot a quarantine zone? Perhaps the simulation detected a virus, a civilization that learned too much, and deleted their sector of space to protect the rest of the program. The sheer emptiness suggests a deliberate wiping of data. We are looking at a reformatted hard drive sector in the sky. Imagine being an observer inside the cold spot, looking out. You are floating in the center of the largest void in existence. For hundreds of millions of light years, there is nothing. But in the far, far distance, you see a wall of light. The cosmic web of galaxies that surrounds the void would appear as a distant, shimmering sphere of stars. You would feel like you are inside a bubble, looking at the universe from the outside. This perspective is alien to us. We see stars everywhere. They would see a wall of fire surrounding a prison of ice. Their cosmology would be defined by the wall. They might worship it or fear it. They would realize they are in a hole. This inverted view of the cosmos highlights how special our location is. We are in the stuff. They are in the space. And as the universe expands, the wall is moving away from them. They are seeing the lights recede, knowing that one day the wall will vanish over the horizon and they will be left in total, absolute darkness. The timeline of the future is dictated by dark energy, and the cold spot is the accelerator. As the voids expand, they squeeze the matter into thinner and thinner filaments. Our Milky Way is part of the local sheet, a filament. Eventually, the Eridanus void and other voids will push so hard that the filaments will snap. The cosmic web will tear. Our galaxy will be cast adrift, isolated from the Virgo cluster and the Great Attractor. We will become like the lonely galaxies inside the cold spot. The cold spot is showing us our destiny: isolation. Currently, we can see billions of galaxies. In 100 billion years, we will see none. The observable universe will shrink to just our local group. The evidence of the Big Bang will disappear. Future astronomers will have no way of knowing how the universe started. They will think the universe is static and eternal, because the cold spot and the expansion will have erased the history. We are living in a privileged time where we can still see the truth. The loss of the night sky is a gradual process, but the cold spot reminds us it is happening. Every second, a galaxy crosses the cosmic horizon and disappears forever, its light no longer able to reach us against the expansion. The universe is deleting its own history. The cold spot is a region where this deletion is advanced. It is a, quote, pre-deleted sector. The anxiety this produces is the fear of forgetting. Humanity relies on history to understand itself. The universe is actively destroying its archives. The cold spot is a burned library. We are trying to read the charred remains of the books, the CMB, before they crumble to ash. We are racing against time to understand the cosmos before the evidence is pushed beyond the horizon. The urgency of studying the cold spot is the urgency of saving the last scraps of knowledge before the lights go out. The lonely Earth hypothesis is amplified by the hostile architecture of the universe. We often ask, where is everybody? The cold spot suggests a chilling answer: dead. If large sections of the universe are uninhabitable due to voids, radiation from collisions, or vacuum instability, then the habitable volume of the cosmos is much smaller than we thought. We might be the only ones because we are in the only safe room in a burning building. The rare Earth hypothesis usually focuses on biological hurdles. Evolution. The cold spot focuses on cosmological hurdles. Survival is not just about biology, it's about location. If your galaxy is in a void, you starve. If it's near a collision scar, you burn. We are in a calm eddy, mistaking our luck for a universal rule. The silence of the SETI programs might be the silence of a graveyard. We are calling out, and the only thing answering is the wind blowing through the empty holes in the sky. The crisis in cosmology is not just a media buzzword. It is a genuine standoff between our best theories and the data. The Hubble tension, the disagreement on the expansion rate, and the cold spot are the two smoking guns. They suggest that the standard model $lambda $CDM is an approximation that is failing. We are like Newtonian physicists trying to explain Mercury's orbit before Einstein came along. We are missing a piece of the puzzle. A new force? A new particle? A new dimension? The cold spot is the anomaly that refuses to fit. It requires us to break physics to fix it. This breakage is scary because we don't know what will replace it. The new model might be even less comforting. It might reveal that time is finite, or that causality is an illusion. The crisis is the sound of the paradigm shifting, and usually, paradigms shift with a violent crack. Consider the mirror universe hypothesis. Some physicists propose a universe where time runs backward, created at the Big Bang alongside ours, to balance the symmetry, Captain symmetry. If this anti-universe exists, Could the cold spot be the connection point, a region where the two universes touch or interact? In a universe running backward, gravity might behave differently, or entropy might decrease. If the cold spot is a window to the mirror universe, it explains the missing energy. It went to the other side. It suggests we are one half of a whole. But touching the other half means annihilation. Matter and antimatter explode on contact. The cold spot might be the scar from a primordial annihilation event where the two universes rubbed shoulders. We are separated by a thin veil of vacuum, and the cold spot is where the veil is thinnest. The rate of bubble nucleation in eternal inflation is a key variable. If bubbles form rarely, we are alone. If they form frequently, the multiverse is crowded. The cold spot suggests the latter. If we have been hit once, the crowd is dense. This cosmic traffic implies a chaotic environment. We are not in a serene void. We are in a mosh pit of universes. This changes our view of the Big Bang from a singular, majestic opening chord to just one drumbeat in a chaotic, deafening noise. The noise of the multiverse is likely gravitational waves. The recent NANOGrav discovery of a background hum of gravitational waves might be the sound of these other universes jostling against each other. The cold spot is the visual bruise. The gravitational waves are the auditory rumble of the traffic outside our home. Speaking of gravitational waves, the stochastic gravitational wave background is the hum of the universe. It is created by supermassive black hole mergers and potentially by primordial events like inflation. If the cold spot was a collision, it should have rung the bell of space-time louder than anything else. We are searching for this specific ringing signal. Finding it would be the smoking gun for the multiverse. It would be a gravitational footprint matching the visual footprint. We are currently tuning our ears, or rather our pulsar timing arrays, to hear this specific frequency. When we hear it, it will be the first time we have heard another universe. It will be the death knell of the single universe theory. We will officially be citizens of the multiverse, with all the existential terror that entails. To really solve the mystery, we need to look at the Dark Ages, the period between the Big Bang and the first stars, 380,000 to 150 million years. The universe was dark, filled with neutral hydrogen. This hydrogen emits radio waves at the 21-centimeter wavelength. By mapping this, we can see the structure of the universe before galaxies formed. If the cold spot exists in the 21 centimeters data, it is truly primordial. It was there before the stars. It is a birth defect. If it's not there, then it formed later, which supports the supervoid theory but requires a mechanism to clear out the gas impossibly fast. The Square Kilometer Array, SKA, will give us this map. It is the next great leap. We are about to turn on the night vision goggles and look into the dark room of the early universe. We might find the monster sitting there, waiting for us to notice it. The impossibility of the supervoid size cannot be overstated. In the time available since the Big Bang, 13.8 billion years, gravity has pulled matter together to form clusters. But to clear out a space of 1.8 billion light-years takes time. Matter has to move from the center to the edge. Moving that much matter that far, even at high speeds, takes longer than the age of the universe in standard models. The void is too big to exist. It's like finding a 1,000-year-old tree in a garden that was planted 10 years ago. It violates causality, unless the universe is older than we think, or the expansion was faster, or the void was implanted there, fully formed at the beginning. The too big to exist problem is a glaring red flag that our timeline of creation is wrong. The structure of the cosmic web is like a sponge, filaments of matter surrounding voids. The cold spot suggests that the sponge is tearing. If the voids grow too large, the filaments stretch and snap. When a filament snaps, the flow of gas to the galaxies stops. Star formation strangles. The galaxy dies. The cold spot is a region where the web has already torn. It is a necrotic patch in the biological structure of the cosmos. If the web tears everywhere, the universe becomes a collection of isolated islands, slowly fading. We are witnessing the structural failure of the largest object in existence. The universe is losing its structural integrity, and the cold spot is the first large tear in the fabric. The Great Filter is usually discussed as a biological or sociological hurdle, nuclear war, climate change. But the cold spot introduces the cosmological filter. Perhaps civilizations don't kill themselves. The universe kills them. Gamma ray bursts, vacuum decay, void expansion, collisions. If the universe is a shooting gallery, the cold spot is a bullet hole. It suggests that long-term survival, billions of years, is statistically unlikely because the environment is too hostile. We are optimistic because we have had a quiet 4 billion years. But in the lifespan of the multiverse, 4 billion years is a heartbeat. The cold spot reminds us that the quiet periods do not last forever. The violence always returns. Let's reconsider the aliens hiding theory with a physics twist. Thermodynamics. A sufficiently advanced civilization produces entropy, heat. To hide, they must dispose of it. Maybe they dump their entropy into the cold spot? Or maybe the cold spot is their cooling system, a giant refrigerator for a galactic empire. This would explain the temperature anomaly. They are pumping the heat out of their region, making it look cold to us, or they are using the void as a heat sink. It's a wild speculation, but in the absence of a natural explanation that fits the math, the artificial explanation remains on the table. We are looking at the AC unit of a Type 3 civilization. A Kardashev Type 4 civilization controls the universe. If such a thing exists, the cold spot might be their construction site. They are re-engineering the cosmos. Perhaps they are clearing out a region to build something massive, or to create a safe zone free of dangerous matter. To an ant, a highway construction site looks like a disaster zone, dirt moved, trees uprooted. To the engineer, it is progress. The cold spot might be the foundation of a cosmic project we cannot comprehend. We see destruction, they see renovation. We are the ants wondering why the ground is gone. The theological horror of the flawed creation returns. If the universe has a defect, like the cold spot, does it mean the creator is flawed, or is the universe a failed attempt? In some Gnostic traditions, the material world is a mistake. The cold spot looks like a mistake. It is an asymmetry, a blemish. It fuels the feeling that something is wrong with the world, not just socially, but physically. The world is broken at the root. The cold spot is the physical evidence of the fall. We are living in a damaged reality, and the damage is visible in the sky. The cosmological natural selection theory, Lee Smolin, suggests that universes evolve. Universes that produce black holes create baby universes. The laws of physics evolve to maximize black hole production. If this is true, the cold spot might be a vestigial organ, or a mutation, a feature that appeared in the evolution of universes but isn't useful. Or perhaps it is a scar from the birth process. If universes are born from black holes, the white hole on the other side might be the Big Bang. The cold spot could be the umbilical scar, where we were connected to our parent universe. It is the belly button of the cosmos. Eternal inflation creates a fractal pattern of universes. A fractal has self-similarity at all scales. If we look at the cold spot, do we see a pattern that repeats? Is there a cold spot in our galaxy, in our solar system? The Great Red Spot on Jupiter is a storm. The cold spot in Eridanus is a storm, or lack of one. The patterns of fluid dynamics repeat from the micro to the macro. This suggests the universe is a fluid. We are living in a cosmic ocean. The cold spot is a whirlpool, or a bubble in that ocean. It makes the universe feel less like a machine and more like a turbulent, unpredictable sea. The Simons Observatory in the Atacama Desert is currently being built to measure the CNB with unprecedented precision. It will look for the B-mode polarization, the twist in the light caused by gravitational waves. This is the key to the multiverse collision theory. If Simons finds the B-modes in the cold spot, the debate ends. We will know we hit another universe. The anticipation in the astrophysics community is palpable. We are waiting for the photo finish. The data from Simons could change human history, proving we are not alone in the multiverse. It is the most important experiment you've never heard of. The James Webb Space Telescope, JWST, is also turning its gold mirrors toward the void. It can see the earliest galaxies. If JWST looks into the cold spot and sees nothing, no early galaxies, no light, it confirms the void is primordial. If it sees galaxies that are wrong, too old, too red, too strange, it confirms the region is anomalous. JWST is the flashlight we are shining into the basement. Every image it sends back from that region is analyzed for clues. We are hunting for the monster with the best eyes humanity has ever built. The Hubble tension might be solved by the cold spot. If we live near a void, matter flows away from us to the dense regions. This outflow mimics dark energy. It makes the local universe look like it's expanding faster. Some scientists argue that we are in a void, the KBC void, and the cold spot is just a bigger neighbor. If we are in a Swiss cheese universe of voids, our measurements of expansion are all biased. We might be wrong about the age and size of the universe because we assumed we lived in a representative average. We don't. We live in the whole of the cheese. What if the galaxies in the cold spot are exiles? In galactic dynamics, three-body interactions can kick a star or a galaxy out of a cluster at high speed. The void galaxies might be the ones that were ejected from the rich clusters. They are the outcasts, the drifters. They travel through the empty dark alone. It gives the void a melancholy character. It is the land of the lost, the island of misfit toys. These galaxies are surviving against the odds, far from the gravitational warmth of the herd. They are the survivors. If physics is different in the cold spot, could life exist there in a form we don't recognize? Dark life? If the sector is dominated by dark matter or different constants, maybe life evolved to use those constants. We look for carbon and water. But in the cold spot, maybe life is based on silicon and methane, or plasma, or pure information. We assume it's dead because it looks dead to us. But to a being made of dark matter, our bright, hot, radiation-filled galaxy might look like hell. The cold spot might be their paradise. The observer effect in quantum mechanics says that measuring a system changes it. Does measuring the cold spot change it? On a cosmic scale, no. But in a participatory universe, John Wheeler, the universe exists because we observe it. We are bringing the cold spot into reality by studying it. Before we looked, it was a superposition of possibilities. Now it is a definite cold spot. Are we collapsing the wave function of the universe into a broken state by looking for flaws? Did we create the monster by searching for it? The information paradox usually applies to black holes, but let's apply it to the void. If the universe is a hologram, the surface area of the void represents a massive loss of bits. A void has less surface area than a cluster of black holes. The entropy is different. The cold spot represents a region where the universe is bit poor. It is low-resolution reality. If you went there, would you see pixelation? Would the quantum foam be visible? It might be a region where the simulation saves bandwidth. The detail just isn't there. Is the universe inside a black hole? It's a popular theory. The cold spot could be the singularity of the parent black hole we are living in, or the point where matter is falling in. If our universe is the interior of a black hole in a larger universe, the anomalies we see are interactions with the event horizon of the parent. The cold spot might be the navel of the black hole, the connection point. It connects the nested universes like a Russian doll. We are deep inside the doll, looking up at the seam. The event horizon of the void is not a hard line, but a gradient. As you approach the cold spot, the expansion of space accelerates. There is a point of no return. Once you cross it, you can never reach the other side, and you can never return to the Milky Way. The space between you and home expands faster than light. You are causally disconnected. The cold spot is full of these horizons. It is a trap. Once you go in, the universe closes the door behind you. You are alone with the phantom energy. We must accept the heat death as the likely outcome of the standard model. Entropy increases, the stars go out, the universe becomes a cold, dark soup. The cold spot is a patch of the universe that has already achieved heat death. It is ahead of the curve. It is showing us the corpse of the cosmos. When we look at it, we are looking at our own grave. It is not a maybe, it is a when. The cold spot is the ghost of Christmas future, pointing at the gravestone. But there is also the cold death. If the universe expands too fast, the temperature drops to absolute zero. The cold spot is leading the way. It is the coldest place in the sky, CMB-wise. It is the absolute zero point. It is the freezer. The universe is freezing to death, and the frostbite started in Eridanus. We are huddling around the fire of the Milky Way, but the fire is running out of fuel, and the cold is creeping in from the void. The Big Freeze is the scenario where expansion wins. The cold spot is the champion of the Big Freeze. It is the victory banner of dark energy. Every year, it gets a little bigger in proper distance. It is conquering the universe. The matter is losing. The gravity is losing. The void is winning. The story of the universe is the story of the triumph of nothing over something. We are the resistance, but we are losing ground. While a big crunch is unlikely for the whole universe, local crunches can happen. But the cold spot prevents a global crunch. It acts as a wedge. It keeps the universe open. It ensures that we will never collapse back into a singularity to be reborn. It guarantees an eternal, cold end. It kills the cycle of rebirth. It makes this universe the last one, in a cyclic model context if it prevents the bounce. It is the terminator of the cycle. Penrose's cyclic universe, CCC, offers hope of rebirth, but only after eons of boredom. The cold spot, as a Hawking point, is the memory of the previous cycle. It suggests that information does survive. So maybe we aren't forgotten. Maybe our supermassive black hole will leave a mark on the next universe. We will become a cold spot for the next species. We will be the anomaly in their sky. We will be the ghost story they tell their children. It is a form of legacy. The eons of Penrose are incredibly long. $10 carat, $100 years. The cold spot is a fossil from Aeon N1. We are in Aeon N. We will create the fossil for Aeon N plus 1. The universe is a chain of universes, linked by scars. The cold spot is the link. It connects us to the infinite past and the infinite future. It is the chain that binds the wheel of time. We are just turning on the wheel. The recycling of matter is efficient in ecosystems, but in the universe, it is inefficient. Matter gets locked in black holes or lost in voids. The cold spot is a landfill. Matter that goes there is effectively removed from the cycle of star formation. It is wasted. The universe is becoming less efficient. It is aging. The cold spot is a symptom of cosmic senescence. The universe is getting old and bald, losing its hair, galaxies in patches. Echoes of the past. That is what the CMB is. The cold spot is a scream from the recombination era. Something went wrong here, it yells, but we only heard it 13 billion years later. We are the forensic team arriving at the scene of the crime eons after the perpetrator left. We can measure the blood spatter, the temperature, but we can't catch the killer. The killer, the collision, the texture, the decay is long gone. The ghosts of radiation. The photons from the cold spot are lower energy. They are tired. They climbed out of a massive gravitational well, or lack thereof. They arrive at our telescopes exhausted. They carry the signature of their struggle. They tell a story of a long, lonely journey through the dark. We catch them and convert them into data. We are listening to the weary travelers from the edge of existence. Is the cold spot the final signal? If the universe is ending, where does the signal start? It starts in the weak points. The cold spot is the canary in the coal mine. If it starts changing, growing, heating up, cooling down, it is the 2-minute warning. We should be watching it 24/7. It is the doomsday clock hand. And right now, it is stuck at 1 minute to midnight. We have reached the 200th scene of our descent into madness. We have explored the physics, the metaphysics, and the horror. The cold spot stands tall as the greatest mystery in the sky. In the final section, we will summarize the ultimate fate of humanity in a broken universe and offer a final, chilling perspective on what it means to be small in a universe that is vast, cold, and careless. The end is near.